All right. So I see most people are done. We have a couple of people who have not responded yet. Please take a look at the poll. Let me know how far you are. Almost done. Okay. So a group of people is almost done. So I'm going to give you another 3 minutes, and then I'll explain how this works. All right, we are going to discuss this, unless you object now. I see nothing. Okay, so let's go over the theory for a little bit. This is a cuvette here. You can see my screen, right? Yes? Okay, thanks. So, a part of you has already done the experiment in the lab, and I think some of you are going to do this on Monday. So you have a cuvette, and what we do with UV-Vis spectrophotometry is that you have a beam of light with intensity P0 coming in, and then there is some absorbance in here. So some molecules absorb this energy from the light, and then light with an intensity of P comes out. All right? Okay. So if you divide P by P0, you get the transmittance, and you can express that as a percentage or as a fraction. So, for example, if we have 10% loss, you would have 90 divided by 100. Okay, so what do we know in this question? We have 18a, right? We have a absorbance. What value of absorbance corresponds to 45% T? So T equals 45.0%, corresponding to 0.45. All right, what is the equation to turn this into a value, absorbance value? Yeah, okay. A equals negative logarithm of T. So let's do that in this case is negative log 0.45. And then you get a value, right? So what's the value? I have that somewhere. Whoops. 18. This is not the one. This is the one. 0.347. 0.347. Okay, so let's do a little exercise here. This is a logarithmic term. Let's do a little exercise. What if you have a transmittance of 100%? So transmittance, absorbance. If you have a transmittance of 1, so all the light passes through, then what is your absorbance? No absorbance? Yes. Yanuk, 0. Okay, negative log of 1 is 0. That's correct. If we have a transmittance of 90%, what is the absorbance? Someone's calculating, I hope, because I'm not doing it. Okay, 0.046. All right, 0.5. Okay, 0.301, 0.1. Yes, okay, perfect. 0.01. Right. 0.001. Okay, 3.0. Okay, you see where this is going, right? Okay, so this one, so I'll take a different color. This means that 10% of the light is coming through. This one means that 1% of the light is coming through, and this one means that 0.1% of the light that we're putting in here is coming out. Okay, so bottom line, when you're in the lab, anything over 1 is useless. Maybe anything over 2 is useless, right? So this is pretty black coffee. You don't see that from the A term. Okay. Let's take a look at B. This is just a bit of background. Let me get the pen. Yeah, here. Let's take a look at B. B. The absorbance of an unknown solution of compound A in the same solvent and cuvet was 0.375. Absorbance equals 0.375 at 238 nanometers. Okay. Find the concentration of A in the unknown. All right. So how are we going to take care of this? What do we do first? This is the right one, right? No. Sorry. I looked at the wrong line in my book. This is 18B. B. Let's take 18A, B first. And let's wipe this away. We'll get there. Let's take a look at this one. If a 0.010, another 0, molar solution exhibits 45% T, at some wavelength, what will be the percent? The percent transmittance for a 0.02 molar solution. Okay, interesting. What did you find? Is anyone still there? 20.25%. Okay. Lokke, would you mind opening your microphone and telling me what to do?
Okay, can you hear me?
Yes, I'm going to make you a little louder. Can you try that again?
Can you hear me?
Yes, I can hear you.
Okay, so the I did the equation of absorbance, and that is the molar absorptivity times B times C. So the length of the cuvet times the concentration.
So you said, yeah?
Yes, and the molar absorptivity and B stay the same.
Okay, this one is the same, and this one is the same. Okay, yeah.
And C doubles, so you can conclude that the absorbance also doubles.
Okay, good conclusion.
And the absorbance, which was measured in question A, was 0.347, I guess. What was the answer?
Yeah, that was the answer.
So 2A equals 0.694. And 0.694 equals the minus logarithm of T, and then T equals 10 to the power of minus 0.964, and that is almost 0.2025, and then times 100%, so that's 20.25%.
Yeah, thanks a lot.
Okay.
And thanks for explaining. Yeah, this is exactly how you do this. Okay, so these were the warm-up questions, I think. How far are you guys? Did you take a look at 18B yet? So I'm going to put out a poll. That's probably easier. If I can get my mouse back to, yes, here it is. So let's stop this one. New poll. Okay, if you could answer this whenever you're ready. All right, so I'll give you a couple more minutes and then I'll check in with you. Some people are still working on it. All right. All right, I can see that most of you are done, some are not, so if you don't mind, I'm just going to start anyway. Okay. Whiteboard. Find a nice clean place here. Okay, 18B. 18. Where is it? Here. 18B, part A. Oh yeah. Also, one thing. If you have questions, open the mic. Just ask me. And if I'm writing too small or you cannot read it or whatever, then let me know. Because I'm writing on one of these drawing tablets, so I cannot see what I'm writing directly, right? So it's all a little messy. So let me know if you cannot read it. A 3.96 times 10 to the minus 4 molar solution of compound A exhibited an absorbance A equals 0.624, no unit, at 238 nanometers in a B equals 1.000 centimeter cuvet. A blank had an absorbance of 0.029 at the same wavelength. Find the molar absorptivity of compound A. Okay, so this is what we know from the question. I always like to write down what you know from the question first. And yeah, okay. So we need Lambert Beer. Already discussed it briefly. And Lambert Beer absorbance equals epsilon times B times C. And in this case, we need the molar absorptivity. So we need epsilon. Epsilon equals A over B times C. And we can calculate this. The absorbance we have to correct for the blank. So we're going to subtract the blank here. 0.229 divided by B, 1 centimeter, times C, the concentration, 3.96 times 10 to the minus 4. I'm going to write this as mole per liter. Okay, then you type this into your calculator, and you would find 1.50 times 10 to the third. So that's the number. We need a unit. So one of you, can you tell me what units you would give this? Open the microphone and just say it. It'll give you a real feeling for an actual tutorial where you would be in the classroom. So the unit is the thing that I'm going to write here, right? No suggestions? We can derive it. Kai says, yeah. That is correct. Yeah. So we have the per centimeter here, and we have the per molar here. So this is a good unit. The other thing you can do is you have no unit here, so 1 divided by centimeters times mole divided by liter. 1 divided by liter. This would go here, so you would have liter per mole centimeter. That's also a good unit. It's basically the same. Thanks, Kai. All right. Questions about this? Questions about why you do a blank? I'm not hearing questions. Okay. The absorbance of an unknown solution of compound A in the same solvent in cuvettes was 0. So A equals 0.375. Find the concentration of A in the unknown. Okay. So first thing we've got to do, don't forget the blank. So this is going to be A equals 0.375 minus 0.029. It's the same solvent, so we can use the same blank. And what we want to know now is the concentration, right? So we have A equals epsilon BC. Rewrite C equals A over epsilon B equals 0.375 minus 0.029 divided by, oops, yep, I get enough, divided by epsilon, 1.50 times 10 to the third per molar per centimeter, times B, 1.00 centimeters, even longer, equals, how much is this? 2.31. Oh. 2.31 times 10 to the negative 4 molar. Did I say that right? Yep, I said that right. Okay, that's the final answer. Questions? Any questions? Type them in the chat. Open your microphone. I see nothing. Continue with C. A concentrated solution of compound A in the same solvent was diluted from an initial volume of 2 milliliters. Oops, 2 milliliters to a final volume of 25 milliliters. And then had an absorbance of 0.733 in the same cuvette. What is the concentration of A in the concentrated solution? All right. That's not so hard, I think. A equals epsilon times B times C. We want to know C in this case again. I'm going to move this up a little bit. There you go. Just ask me if you want to see other stuff again. And C equals, A divided by epsilon times B. And this we're going to fill in. Equals 0.733 minus 0.0, what was the blank again? 29, I think. Divided by 1.50 times 10 to the third times 1 centimeter. And we diluted this uh, 12 and a half times, right? So we need to compensate for that. So if we type this in the calculator, you would get 5.87. 5.87 times 10 to the minus 3, I think 3, yes, 3 molar. Okay. Why would you dilute this in the first place? Why not just analyze it straight away? Any suggestions? No suggestions? Or maybe someone's still typing. Okay, so probably the absorbance of the original sample is way too high and you cannot measure it accurately. All right, this was 18b. Questions about 18b still? If not, then we can actually move on to the problems. And 18.2 is the first problem that we're gonna look at. So take a look at 18.2. Problem 18.2, and then problem 18.23. Let's see. 18.18. Right, 18.18. 18.18, and then we're going to take a look at 18.23, and that's 18.22 in the 9th edition. Harris. Okay, take a look at 18.2. I'll put out a poll and see how far you guys are, so we can discuss this. This is a more physics-related problem, this first one. All right, good luck. All right, just checking in on you. I see many people are already ready to discuss? That's okay. If you're not ready to discuss, that's okay. Click no. Give you some more time. From the people who are ready to discuss, is that because you're done calculating, or you don't want to calculate, just want to see the explanation? So I'll ask you again. Did you figure out the calculation or not? Okay, Mouts, you think you figured it out? Okay. That's good. I know it's Friday afternoon. I know it's late. Why is the energy in kilojoule instead of joule? Yeah, I don't know. It's just divided by 1,000. It's probably easier or common. I don't really know. Okay, let's take a look then. I see no objections. So let's take a look at 18.2. So what do we have? We have the no. So the question is, what is the number? Whoops. Just trying to reorganize my screen so that I can see my whiteboard. All right. So the question is, what is the number of kilojoules in 1 mole of photons at 650 nanometers? Okay. There is probably a reason you want to know this. We have this this equation, E equals H times nu. So not a V, this is a nu. And H is Planck's constant, which is 6.626 times 10 to the negative 34 joule seconds. And nu is that's the frequency, so it's a per second thing, which can be calculated by dividing c by lambda. And c is the speed of light, which you all know is 2.998 times 10 to the 8th meters per second, so 300 million meters per second. This is a constant. Divided by lambda. Now, lambda in this case is 650 nanometers, so 650 nanometers. Okay, so this stuff, what nano means, that's something you just have to know. All right, so we're going to put this guy, oops, and this guy together. Then we're going to have E equals 6.626 times 10 to the negative 34 joule seconds times 2.998 times 10 to the 8th meter per second divided by 650 times 10 to the negative 9 meters, and you would get a number of 3.06 times 10 minus 19 joule. Okay, that's not a lot of energy, right? But now we need 1 mole, and 1 mole equals, and then we need Avogadro's number. Avogadro, and that is 6.0 0.022 times 10 to the 23, I think. Yes. So this is a number, right? So a number. So we multiply this one and this one. Then we get the joules. It was per mole, right? Was it? Yes, it was per mole. Okay. So we multiply this, and then we get 184 kilojoules. All right. Questions? No questions? If you have no questions, I'm just going to move on with part B. Yes, I hear a chat thingy. I cannot follow the last step. Okay, that's okay. Go back up. All right, so what we have here is the energy per photon. And now we want to know how much energy there is in 1 mole, right? So 1 mole is a number. So you can have a dozen, which is 12. You can have 100. This is just a very big number. So what we're going to do, cross this out, is we have 3.06 times 10 to the negative 19 joules times 6.022 times 10 to the 23. And if you multiply these numbers, do I have a calculator here somewhere? I think I do. Yeah.
Yeah. Okay. Thank you.
Oh, you already see it?
Yeah, I already see it.
Okay.
That
So this.
an amount of energy was for 1 photon, and then times 1 mole.
Yeah.
Is for
Exactly.
the photon, then you have the total amount.
Yeah. So and then you get 184 times 10 to the third joule, and then that's 1.84 times 10 to the. I have to say this right. 10 to the 5th joules, right?
Yes,
Yeah.
and then 2 kilojoules.
And then one. Now I'm screwing it up. 184. Sorry, 184 kilojoules. Yes.
Yes. Thank you.
Sure. Okay. So now we're going to do B. B is very similar because that is. Where is it? The same thing, but then at 400 nanometers. So we're going to do this again. E equals H times nu equals H times C over lambda is 6.626 times 10 to the, what was it again? Negative 34 times 2.998 times 10 to the 8th meter per second divided by 400 nanometers. And this would give you a number, and that number should be 4.97 times 10 to the minus 19th joule per photon times Avogadro. So same step as above. 6.022 times 10 to the 23rd equals 299 kilojoules. Interesting, right? So if you compare this one with that one, then the bottom line is shorter wavelength means more energy. All right. Okay. Let's move on. The next one is 18. 18. Oops. No, don't do that. Next one is 18. Oh, I lost my. Oh, here, 18. Yes, the next one is 18. I'll give you a couple minutes and I'll check in with you with a poll. Oh, and one more thing. We're halfway through this tutorial, so good that you're still here. That's nice. I'm gonna get a cup of coffee. Maybe you should do the same. It's a little early for something stronger, but just so you know, take a break, take a walk, and see you in a bit. All right, take a look at the poll, please. You can change your answer later. So just so I know how you guys are doing. Thanks. Okay, I think I know some people are still working on it, but I think this would actually be a good time to start discussing this. Let me know if you really seriously badly disagree. I hear nothing, so I'm starting. We're going to take a look at 18. Whoops. Black pen. 18. Okay. So what do we know? A compound with a molecular mass of 292.16 grams per mole was dissolved in a 5 milliliter flask. Okay. We take a 1 milliliter aliquot, which is just an amount, placed into a 10 milliliter flask and diluted to the mark. Absorbance at 340 nanometers. Absorbance at 340 was 0.427 in a 1 centimeter cuvet. Okay. Oh, we get one more thing. Epsilon 340 is 6130 per molar per centimeter. Okay. All right. The question is, what is the concentration of compound in this cuvette? So for your exam, of course, you're very interested what you should do in the exam, right? I always like to write down the things that I have just to organize these data. I personally don't like these stories. I just like a list of numbers, but that's up to you. Calculate the concentration of compounds. Okay, so this is the equation we're going to use, and we need the concentration. It's A divided by epsilon times B is 0.427. And it's strange, but they don't say anything about blanks here. So they probably blanked the machine already. So they used a cuvette with solvent first, hit 0, and then moved on. Divided by 6130 per molar per centimeter times 1 centimeter. And then we get 6.97 times 10 to the minus 5 molar. Okay. That was all. Simple exercise, I think. Let's go to B. So this is the concentration in the cuvette, right? With B. And in A. And in B, they ask what was the concentration of the compound in the 5 ml flask. Okay. So we've done a dilution. And the dilution also. So we did a dilution here from 1 ml to 10 ml. So the concentration in the flask is 10 divided by 1 times 6.97 times 10 minus 5 molar equals 6.97 times 10 minus 4 molar, 10 times higher. Okay, C. How many milligrams of compound were in the original 5 ml? Okay, so we know it was, we have C equals 6.97 times 10 minus 4 mole per liter. That's the same as molar, right? Times how much do we have in the beginning? That's here, 5 milliliters. 5 milliliters. Okay, so then mole, I'm going to explain how this works. Mole per liter times liter will give you moles. Okay, and then we're going to multiply that with 292.16 gram per mole. And do this one. So it's always good to look at the units. So mole divided by mole, liter and liter. So we get an answer in grams here. Then if we work the math out, you would get 1.02 times 10 to the minus 3. And that should be converted to milligrams, 1.02 milligram. Okay. I think this is the essence of the Lambert-Beer or Beer-Lambert law. Any questions here? I would say this could easily be an exam question, something like this. So make sure you understand this stuff. I personally think that UV absorbance is not so hard. I'm not sure if you agree. You may, of course, disagree. All right, then let's take a look at the next exercise. We're going to do 1823. And if you have the other version of the book, that's going to be 18. So now we're going to take a look at 1823, but only A and B. And that's 1822 in the 9th edition. And it should be a question about bacon and nitrite. Oops, nitrite. Okay. This is a longer one, and this is a mathematical problem. I'll give you a couple minutes. No, I'll give you until 5, and then we'll discuss it, I think. I'll put out a poll if you guys are finished early or you give up early. That's fine. Don't worry about it. Then we'll start early. All right? Okay, good luck. Okay, so let me know how far you are. So just update your status when you're progressing. I think it's possible to change your votes in this poll later. So just let us know. Okay, so many people are actually fighting their way through this one. I see a couple of people are done. That's nice. We have about a half hour left, so I suggest that we start in a little bit. If you've given up, that's also okay. That's what the tutorials are for. As long as you don't give up on the exam, then I'd be very happy. This is to practice. You can always practice again later. You exercise again. Whoops, all right. So let's see, this one's difficult. I'll give you that. I just wrote down what we have here. So we have 50 milliliters of solution. We add several things. Sample A is the blank. Sample B is the sample solution from, I think, bacon that contains nitrite. And sample C is a sample solution that was spiked with extra sodium nitrite. Okay, so now we need to calculate epsilon. So how are we going to do that? We need two things. So this is more of a mathematical problem. First, we need to calculate for these samples the corrected value. So we're going to subtract this from the other two. And this one is going to be 0.622 minus 0.153 equals 0.469. This one 0.967 minus 0.153 equals 0.814. Okay, first couple of points are in on the exam. That's nice. Okay, so we have this. Now we need to calculate the epsilon. Okay, so how are we going to do that? I'm just going to scroll this. Let me know if I need to go back up. So we are going to fill out the Lambert-Beer equation. We have A equals epsilon BC, and C equals 5 centimeters. So it's a very long cuvette. Okay, so A sample. So that's sample B in this one, right? A sample equals 0.469, and that is epsilon times B times C sample, the concentration of the sample. We don't know this one, so that's a problem. But what we do know is that we have a sample plus extra nitrite. So that's this one, sample C is 0.814 is epsilon times B times C sample plus C sodium nitrite. Right? So this has two sources of nitrite, the stuff that was in the bacon, that's this one, and the stuff that's been spiked, the extra sodium nitrite. Okay? Everyone is still following? Okay, good. Going to rewrite this one to epsilon equals 0.469 divided by B 5 centimeter times C sample. Okay? Same stuff as here, but then rewritten, different order. And now we are going to use these two equations, and we're going to substitute this in here. Okay? So what we're going to get is 0.814 equals, I'm not writing epsilon, but I'm writing this, 0.469 divided by 5 times C sample times B times C sample plus C sodium nitrite. That's the same as here, right? This bit. Still following? Okay, that's good. All right, so now we have to get rid of the B and put a 5 there. And now you're going to have to do the math. Now you're going to have to do the math. Okay, that's all very nice. But we have one equation and two unknowns. We have C sample here, and C sodium nitrite here. One equation with two unknowns. You're never going to solve this. Okay, so we need to figure out what this one is. Can we? Yes, we can. Because it is given in the question that 10 microliters of a solution of 7.50 times 10 to the minus 3 molar nitrite was used. And then we can multiply these two. And then we find that this is, look at the answers here. Okay, I don't know. Okay, so this is a certain number of moles. And then the total volume is 50 plus 1 plus 2 plus 1 is 54 milliliters, right? So we're going to, this number of moles, and then divided by 54 milliliters. Then we get a concentration of sodium nitrite that is, where is it? There, 1.39 times 10 to the minus 6 molar. Okay, questions about this part? And this should be 7.50 times 10 to the negative negative 9, negative 8, I think. Something like that. No questions? All right, then we're going to carry on. So this one right here is the concentration that we needed here. So I'm going to move down a little bit again. We're going to write this again. And then we have 0.814 equals 0.469 divided by 5 times C sample times 5 times C sample plus 1.39 times 10 negative 6. All right. Oh, that's very nice. So here, oh, whoops, sorry about that. Do that again. Yep. Oh, this is too bad. Okay, this is a rectangle. Sorry. Okay, so here we have one equation with exactly one unknown. So this is something you can solve. All right. would you like me to show how to solve this, or I'm actually pretty sure that you can do the algebra here. Otherwise, I'm just going to give you the final answer. Let's say multiple steps. C sample equals 1.89 times 10 to the negative 6 molar. Can you show it? Yeah, I was kind of asking for that, I guess. Yes, I can. Right, so can I show it? Let's take my red pen and make my life a little easier first. 5 divided by 5 is 1, so we can cross that out. And then let's see what else we have here. This times that. So we can actually make this 0.814 equals 0.469. And now we're going to put this guy to the right, plus 0.469 times 1.39 times 10 to the negative 6 divided by C sample. Then we can rewrite this as 0.814 minus 0.469 equals sorry, not equals. Nope. No. Don't do this. Stupid thing. Okay. Right. This one minus that one times C sample equals 0.469 times 1.39 times 10 minus 6 molar. And then in the end, we get C sample, right? Only this thing equals 0.469 times 1.39 times 10 negative 6 molar divided by 0.814 minus 0.469, and then we get 1.89 times 10 minus 6 molar. Did you follow that, or was it too fast? Right. Then there's still a part B, I think. That's the, I followed it, but there's twice a C sample, right? Yes. So it's in 2 parameters, but I took it out of there. Okay, cool. We will actually post these solutions also on Nestor, so you can check the solutions again, like next week or whenever you have time. Let's take a look. There's a part B. I hear no other questions, so I'm going to move on. There is a part B. How many micrograms of, okay, how many micrograms of nitrite, NO2 minus, were present in 50 ml of food extract. In 50 ml food extract. Okay. So let's take a look. Right. So what have we done? We let's get this out of the way. So we know the C sample, and we know this is a dilution formally, because we now have 54 ml, and it was originally 50 ml. Right, so we've done a very tiny little dilution here. And what else do we know? We need the molecular weight of nitrite. Okay. We know the concentration of the sample is 1.89 times 10 to the minus 6. Go mole per liter times dilution factor is 54 divided by 50. Actually, no, that's not right. This is not the one with the 10 microliters extra. Okay. Times the molecular weight of nitrite. And I don't think they give that in the question, do they? No, they don't. Right. Locally, yes, you're right. I forgot a part. Okay, I'll finish B and then we'll go back to A. Remind me. Yes, you're absolutely right. We had to do molar absorptivity. I'm going to finish this one. This is 46.055 grams per mole. And then we get 4.69 times 10 minus 6 grams. And this corresponds to 4.69 micrograms of nitrite, NO2 minus. All right, questions about B before we go back to A and finish that one? Because Lobke is absolutely right. We now know the concentration. So now I'm back at A. C equals this. Then we have A, B, C. Rewrite epsilon A over B times C. Epsilon equals absorbance was 0.469, right, for the sample, divided by V is 5 centimeters, and C is what we just calculated, 1.89 times 10 minus 6 mole per liter. It's a little longer. And then if you do the math, you should be getting 4.97 times 10 to the fourth liter per mole centimeter. Sorry, Locke, thanks. Questions about this part? So yes, I would have missed the final 2 points in the exam, I guess, for skipping the final answer. Okay, Let me see. I don't think there's anything else on the menu for today. Nope. So that was it.